The classical pathway C1q activation. C1q binds to, recognize, the Fc region of IMORIG that bounds to antigens. Such binding leads to conformational changes in the C1q molecule, which leads to the activation of two C1r molecules. They then cleave two C1s molecules. The C1qR2S2 splits C4 and C2, producing C4a, C4b, C2a and C2b. C3 convertase of the classical pathway. C4b and C2b bind to form C4b2b. C3 convertase, C4b2b, cleaves C3 into CEA and C3b. C3b joins with C4b2b to make C4b2b3b, that's called C5 convertase. Common pathway. It starts with the production of C5 convertase which cleaves C5 into C5a and C5b. C5b will bind to the surface of the target cell. C5b binds to C6 forms C5b6 unless it will be rapidly inactivated. Up to this moment the reaction take place in the hydrophilic surface of the cell membrane. C7 binds to C5b6. C8 will bind to C5b67 exposing the hydrophobic region. C5b678 create a small pore that can lyse RBC but not nucleated cell. The final step is binding of 10 to 14 molecule of C9 to C5b678 complex to form the membrane attack complex, MAC, which is inserted into the cell membrane, punches a hole, and initiates cell's lysis by influx of water and loss of electrolytes. Alternative pathway. It does not need antibody for its activation, so it is a component of innate immune system and it may be activated by one of the following factors. LPs from GM-V bacteria. Teichoic acid from GM plus V bacteria. Zymosan from fungal and yeast cell wall. Some viruses and virus-infected cells. Many non-pathogenic antigens, heterologous RBCs, dextransulfate, pure CHO and copper venom factor. Spontaneous C3 hydrolysis. Spontaneous hydrolysis C3 contact with microorganisms to be cleaved to C3a and C3b. Then factor D cleaves factor B into BA and BB. BB will bind to C3b to form C3 convertase. The C3bBB is stabilized by properdin. C3b binds to the initial C3bBB to form the C5 convertase of the alternative pathway C3bBB-C3b. After production of C5 convertase, the common pathway will start and complete like previous. And here is a comparison between classic and alternative pathways.